morning. My name is Nuno, and I'll be talking about ranking hotel images using deep learning. So first, I'll introduce Expedia, the company I work for, then talk a little bit about why we want to rank hotel images, and then finally talk a bit about the approach and show some samples and also some results. A little bit about me. So I worked for Expedia for 3 years, ran a data science team there. And before that, I worked in credit card fraud detection, also using machine learning. And before that, I did an internship in big data at Siemens. I also did a PhD in machine learning and computer science. And I actually started out as a software developer, as many of you probably. A little bit about Expedia. So Expedia is one of the largest travel companies in the world. It's about 70 billion in gross bookings and about 9 billion in revenue. So if you think about the number of transactions we have per day, that generates a lot of data that we have a lot of fun with. When you think about Expedia, actually, it's not just Expedia.com. Expedia is actually a family of other brands. So you probably heard of Hotels.com, probably HomeAway or Trivago are also part of the Expedia family. Some of them focus more on online travel with flights and hotels and car rentals like Expedia, but some others like Hotels.com are based only on hotels. And Trivago is our meta player. So of all these brands, I work for the B2B part of the business, Expedia Affiliate Network, or IAN. At IAN, we don't have a website. Basically, we have an API that empowers other businesses like airlines to add hotels to their flights. When people book a flight in one of these airlines, sometimes you are suggested, do you also want to book a hotel? And then if you say yes, it's likely that Expedia will be providing that hotel through IAN. So in terms of inventory, we give all of our 300,000 hotels to all of our partners, and we have about 7,500 partners that we work with. So each of those is a separate company, an airline, or actually a brick-and-mortar travel agency that you can see on the street sometimes, and they are being powered by IAN. You may know a few of the brands, so Swiss Airlines, Norwegian Airlines, eDreams, Aerobookings, and many, many more that we can't talk about because some of our the work we provide is white label. So why is it important to rank images, right? As humans, we are visual machines. It takes us about 1/20th of a second to process an image or to recognize someone's face. That's 4 times faster than blinking an eye. If you think about it, it's really fast. It's just the way our brain is wired. The first thing we process when we look at something is the image. And if you transpose that to the hotel business, when you're actually looking at the hotel, the first thing you see is the image, right? Before you even think about the price or the hotel name or anything else, your brain is just wired to process the image first. You'll give you that primal instant if you like it or not, straight away. And then, after a few milliseconds, you look at the price. And then you look at the star rating, TripAdvisor rating. And finally, you read the text, and that takes a lot longer. But the first thing is always the image. That's why it is so important. And some images are really good, and some other images are not so good, right? And because there are many, many hotels and many, many images, this is a very hard problem to tackle for humans, right? So at Expedia, what's currently happening is that the featured image or the first image is manually selected, so that one is generally OK. But then all the other images are either randomly sorted or they are grouped together. For example, the first 10 images would be the lobby, the second 10 images will be the bedroom, and so forth. So especially if you're on a mobile device, where you only have time or patience to look at 3, 4, 5 images, right? If all of those are related to the lobby, you will just go and book another hotel or go to a competitor's site, right? So that's why it's so important. And if you think in terms of optimization and conversion, sometimes just changing the color of a button can give you a 1% uplift in your revenue. Or if you want to get a bit more elaborate and change the sort order of the hotels you provide to different customers, that can give you a 3% uplift. So we think changing something as primal and important as images will likely provide also a very good uplift in revenue and conversion. So if this is so important, why are we not doing it, right? So there's two main reasons: scale and complexity. So in terms of scale, we have 10 million images. And for that reason, it's very difficult to do manually. And also, if you think about it, you have many different customer types. Like a business person may like a conference room image better than a family person. A family may actually like a swimming pool or a playground area better. So if you multiply all of those possible combinations by the 10 million images that we have, you suddenly have a very difficult problem to do manually, right? And the second reason we're not doing it is complexity. So even for us as humans, to say if two things are similar, there's a lot of subjectivity to that, right? Similarity is subjective. And for machines, as you know, at least up to 5 years ago, all images could do in terms of image processing would be considering the edges and the shapes, using some thresholded techniques or something a bit more advanced than that. But it was not very elaborate, right? So those are the two main reasons we haven't tackled this problem before. The technology was just not there. But recently, as you know, there have been advances in deep learning, in self-driving cars, personal assistants, VR, all of these exciting things that all of you talked during these 3 days. So it feels like the right moment to use deep learning to solve this problem. So essentially, we focus on ranking or sorting hotel images within each hotel using deep learning on our about 300,000 hotels and then 10 million images. So to do that, we follow a 3-step approach, essentially. So first is building a data set. As you know, as data scientists, that's often the most difficult part and where you spend most of your time. After you have a data set, you're going to train your model. And finally, you're going to look at the results and see how they are. So in terms of data set, we actually use the Amazon Mechanical Turk. How many of you are familiar with the Mechanical Turk? That's decent. Essentially, it's a crowdsourcing product by Amazon that allows human workers to essentially do repetitive tasks for you. So what we got from them was ratings from 1 to 10 for each of the 100,000 images. So this is only a subset of the 10 million, sort of all of the image set we have. We gave to the Mechanical Turk 100,000 images for them to rate. And we got them to rate each image 6 times on average. So that means we have about 500,000 human ratings in our data set. So each rating is from 1 to 10. And we also ask the raters to describe what sort of traveler they are. Are they a business traveler, a luxury traveler, a family traveler? So in the future, when we want to actually explode the complexity of the problem to traveler type, we already have some of that data in. In terms of results from the Mechanical Turk, our average score is actually 6.5 from 1 to 10. We declined about 5% of the ratings because basically they were cheating or automating the process. And this cost us $3,000. So it's fairly cheap to get 100,000 ratings only by $3,000. And took less than a week to get all the ratings. So it was a fairly efficient process in the end. These are some of the top images according to the Mechanical Turk rating. And these are some of the bottom images. So after you have a data set, what do? You basically train a model, right? To iterate your machine learning process to train a model. And you divide the data set typically into a train and a test set, so about 2/3 for training and 1/3 for test. Essentially, the data looks like this. So you have the path, the URL for the image, and then you actually have the rating for the image. So the rating you have for each image is the average of the 6 scores you got from the mechanical Turk. After some cleaning, because some of the images you have very wide distribution, so we sort of clean the data set a little bit, and when in the end you only have one number per image. And in terms of modeling, we actually started with the VGG pre-trained data set. So most of you, who knows about VGG? So VGG is essentially a model that's pre-trained on ImageNet. It's pre-trained on 14 million images, and the objective is basically to classify each image in one of 1,000 classes. So this pre-trained model achieves about 92.5 top 5 accuracy on this data set. And in terms of architecture, you essentially have your convolutional layers, and then in the end, you have your fully connected layers. After softmax, you get the 1,000 classes in the end. So you can get this out of the box without requiring you to do anything. And this model is really good at detecting objects in images. And what you do then is use a technique called transfer learning. So essentially, you use your pre-trained model, which is really good at distinguishing between different objects, right? And then you take the first part of your model, and then you fine-tune it on our data set, right? So you keep the first part, and then replace the last part, and then you train that on your data set. This actually saves you time from training everything from scratch, and you also leverage a lot of the learnings from VGG. So in terms of architecture, previously we had the classifier in the end. What we do is essentially remove that classifier and replace it by a regression, where the objective is actually to return a number from 1 to 10. So essentially, in the end, in your fully connected layer, you have, in the end, a single neuron with your prediction. There's a few things you need to change. We actually use Keras to do this. Basically, you just change the output layer, and we created a generator, a Python generator, for the regression model. Because originally, you actually need 1 folder per each class, so you have 1,000 folders. So we essentially changed that bit of the code to use a rating for a rating problem, where it's all in 1 folder, and then you have 1 file with all the mappings between the URLs and the ratings. So the model essentially looks like this. You load your VGG model, and then you essentially have 2 fully connected layers with some dropout, and in the end, you have 1 neuron with your prediction. So fairly simple. Once you have the model, you're going to train it. So you basically compile it. We're actually using Keras with the TensorFlow backend. So this essentially compiles it to TensorFlow. And then we just call fit. And this will actually train your model. So after you train, you can test it or run it. And that's essentially calling predict. And using this model, we got a 0.5 mean average error on our data set, on our test set, on a scale of 1 to 10. And in terms of percentage, there's about a 12.5% error. In terms of the setup, we're using Keras. So as most of you may know, this is a high-level neural network API in Python. And we selected the TensorFlow backend to run us. So this allows us to focus on experimenting and iterating quickly, rather than having to worry about all the TensorFlow details. In terms of environment, we use a 8 GB GPU locally, and also some other GPUs on AWS to give us a bit more parallelization for the test step, which is our main bottleneck. So there were a few optimizations that we needed to do. What we found is that the GPU was actually waiting a lot of time when you look at the process operative system. The GPU is actually waiting for the CPU a lot. So we basically created an optimization where we created a queue to essentially have the GPU always being consuming things from the CPU. So basically create multi-thread and multi-threaded that part of the code. And on the inference part, actually, we did some data parallelization because this is our main bottleneck. We have 10 million images that were taking like a week to score. So this actually improved to 1 day. In terms of results, so on the left-hand side, on the right-hand side, there's the existing approach, so the top 24 images for this hotel. So you see the first image is really good, but then you have a combination of lobby images and then bedroom images. So if you're on a mobile phone, you never go past image 4 or 5, so you'll never see the nice pictures from the outside. And then you see the top images as predicted from our deep learning model on the middle, and then the bottom 4 pictures as predicted. So it seems to be working fairly well. A few more examples. So again, your lobby, your bedroom, and then your exterior. This hotel has a lot less images than the one before. And then it seems our machine learning algorithm is doing a lot better than that. Another example. In this one, there's actually some weird images. I don't know what is that. But it seems to be captured fairly well, which is interesting. So that was it. Essentially, we introduced Expedia, motivated the problem, and then explained a bit the approach and showed some results and code samples. If you have any questions, please reach out to me or Feng, who is actually the lead data scientist in this project. And we're also hiring, so if you like to work on these and other cool problems, please reach out. Thank you.
Time for Q&A, so put your hands up if you have any questions.
Hi there. I just want to say thanks. Really interesting talk.
Thank you.
It looks like it shows a lot of promise. I guess, I mean, the biggest problem with a lot of these sort of big machine learning style frameworks is your ground truth. And I was just wondering what your sort of feeling was on using Mechanical Turk. Do you think there's a sort of a bias in the type of person that might use Mechanical Turk as opposed to using Expedia? And would that bias the results? Are you getting enough, maybe younger people use Mechanical Turk as opposed to Expedia, et cetera?
Yeah, I think that's a really interesting question. Yeah, I think there may be some bias. In terms of sort of where the ratings were coming from, most of them were coming from the US and India. So you may have some bias on the cultural aspects of those countries, which may not reflect the entire population. So one of the questions we had, how many ratings should we have for each image? And we did a few small experiments, and we decided to go with 6. But obviously, if you have more ratings, that could also be an approach. But yeah, I think this is a really interesting point and should be considered. In terms of timeline of the project, this is basically getting us started and getting model live on our website, on one of our partners' websites that we can A/B test. And then we need to be able to look at actually what's happening on the partner website, what's happening after customer looks at a particular image, right? So when we have those data, we can then close the loop and make this sort of full process automated. But this mechanical Turk data set is to get us started and to get that loop essentially rolling.
Hey, thank you for the talk again. I would like to ask, at the beginning you described the problem that users might be different, like they might have different tastes and all that kind of stuff, but at the end this wasn't really included in the model, was it?
No, so that's future work. At the minute we have one static model that will apply to every customer, and then as we iterate on that model and get the results, we will work on that part, which should be the most exciting one.
Okay, just the follow-up. What was the distribution of the customer type? So on the mechanical Turk, when you asked for the classification, what was their distribution of the answers? Because I guess there weren't like many business customers.
Surprisingly, there were a lot of business travelers, and we actually had 9 different categories. So it was business, family, luxury, middle class, solo, group, friends. So, and we actually limited the number of categories to 3, so that in the initial experiment, we didn't limit, and they were like selecting 6 or 7 different categories. So we said, okay, each person can only select 3. And it's actually fairly well distributed. Surprisingly, there were a lot of business travelers in the mix as well.
Thanks for the really nice talk. Could you just say, did you try your classify without the transfer learning part?
In what sense? So basically,
just on your data alone.
Yeah. So we have sort of a Flask app where we basically inspect our results, and in that app we also have the sort of labels provided by the classifier, and then overlay that with the final score.
Thanks for the talk.
Okay.
One question: when you had some of the images, it was showing a nearby beach or something which might not be the hotel as such. How do you make sure they don't have outliers which misrepresent the hotels?
Can you repeat again, please?
When you have all the pictures, some of them is a nearby beach, something which isn't the hotel as such. How do you make sure you don't have outliers which overrepresent or underrepresent a hotel? In this case, overrepresented, give it a higher rating than it should have had.
So do you mean because
Because you
pictures
just
are
take
actually
the nicest picture, which
Yeah.
might not necessarily be the hotel. You could take the average of all the scores of all the pictures and make sure it didn't have an outlier. But how do you make sure that it is something which is a good representation of what you're actually looking at?
Yeah, it's a good question. I think it's something we're still working on. What's under consideration is should our output just be the final score of the algorithm, or should we actually sort of limit what goes into the top 5? Like, should we just get top bedroom, the top lobby, the top exterior, just to sort of guide the ranking a little bit, or should we let just the algorithm, whatever, if the first 10 images are of the beach and those are the nice pictures, just display those? So we're still exploring that, and I think a lot of those learnings will come from A/B testing in the real world. But it's an interesting problem.
A quick question here. Hi, thanks for your talk. I'm just interested to know, is this model in production? Is it integrated with the Expedia website that we see today? And what is the process of putting data science in production that you follow?
So we're currently A/B testing with one of our 7,000 partners. So this is at the minute not linked to the main Expedia.com brand. We're actually kicking this work off separately on our own brand, on Expedia affiliate, and in collaboration with hotels.com as well. So initially, we'll be on a partner so a separate company that's using our inventory. And then if we have good results, we'll roll it out to the other brands as well. But in terms of the process we follow is typically we test on a small subset of traffic, and then depending on the result of the A/B test, we roll it out accordingly. But the business is typically open to those tests.
Hiya, so over here. You said you declined about 5% of the ratings. How did you detect and determine that? What was the pattern there?
So essentially, some of the things we did, we just loaded everything to a Python notebook, and simplest thing, just look if all the ratings are the same, and then look at the timings between the ratings as well, and also looking at the distribution. So it's not super sophisticated. I guess we could do a bit more work there. But we didn't really see the need at this point because we didn't see a lot of...
Was it pretty obvious?
Yeah, the cheaters were pretty obvious. And we thought the value we would spend in, for example, writing some outlier detection would not give enough benefit, but it's something we sort of thought a little bit about. But it's a good, good problem, yeah.
Any more questions?
The problem you mentioned with the training being CPU bound, was that a problem with the Keras library itself? Was it related to streaming the images off the disk to play it through the gradient descent? Do you know any more details about that?
Yeah, I think it's generally with the current TensorFlow implementation.
Okay.
So if you look at the sort of all your processes and what the GPU is doing, if is it idle or is it being used, and at what percentage? What we observed is that actually the CPU was 100% and the GPU was actually idle a lot of the time.
So you had to go and make some modifications to the core TensorFlow code?
Yeah, so essentially is basically just writing a multi-threaded version to, not to the TensorFlow, it's actually the way we load the batches.
Right, okay, yeah.
So essentially just change that bit that loads the data and multi-thread it a little bit.
Thanks.
Thank you for the presentation. The question I have is, how were the pictures collected? Were these sent in by your clients? Or did you send people out there to take them? That'd be difficult. But then, do your clients have the ability to improve on their pictures? Like they continuously send in new pictures and they get rated, I guess, more automatedly in the future to improve their profiles?
So the pictures actually belong to Expedia, and they were taken both by the hotels themselves or by someone working at Expedia in the past that went to the hotels and take the pictures when we onboard the new hotel. So that's essentially how it works. In terms of the collaboration with the partners, when we are A/B testing something like this with any of the partners, they are actively involved in that test. Does that answer your question?
So your partners are aware that there is value in improving the pictures, and therefore they can actively actually do that.
Yeah.
Thank you.
Thank you.